Good morning, everyone. My name is Tracy. Today, I will present to you about gas chromatography. Gas chromatography is an analytical technique used to separate components in mixture without decomposing them. It can be used to determine volatile components such as fuels, drugs, and food. Separations of mixture depends on the size of molecules, boiling point, column temperature, affinity and solubility of to the stationary phase. Fundamental principle of GC is the equilibrium. Gas chromatography is partitioning and components of the mixture with partitions between two phases, stationary phase and mobile phase. Compounds which have greater affinity for stationary phase spend more time in columns, hence have higher retention time. Compounds which can be analyzed by GC must have boiling point up to 400 degrees Celsius. Compounds that are not decomposed at a vaporization temperature. Organic compounds which do not vaporize, highly reactive or chemically unstable, cannot be analyzed by GC techniques. This is the structure of GC instrument. As the sample is injected to the column, carrier gas, which can be nitrogen or helium, is released as a mobile phase, which carries the sample to the columns. The column is heated to a certain temperature. The analyzed in the sample start interacting with the stationary phase. The polarity of the sample decides the type of stationary phase which can be used. The analyzed which have lower affinity or solubility to stationary phase would move faster in column to the detector. At a detector, the analyte is broken down into ions. The amount of ions generated is detected by the computer and generate a peak. The amount of peaks generated in the chromatogram indicates the amount of different components in the mixture. Sample preparations. Most of the samples are not ready to be directly injected into the instrument. They need to get prepared. Sample preparations is often several process that account to the complexity of the analysis. Sample preparations procedures can be mentioned as extraction, cleanup, derivatization, transfer to vapor phase, concentration. The basic concept of sample preparation method is to convert a real matrix to a sample in a format that is suitable for analysis by the separation or other analytical techniques. Extraction technique. There are two major kinds of extraction: solid phase extraction and liquid extraction. In solid phase extraction, the analyte can be separated from the solid, while in liquid extraction, the analyte can be separated from the solution. By optimizing the extraction conditions such as temperature, pressure, and pH of the solution, and also appropriately using additive, and reagents, the selectivity and yield of the extraction process will be improved. The concentration techniques. If the amount of solvent to be removed is not very high and the analyte is non-volatile, the solvent can be vaporized. Gently stream of nitrogen gas flowing either across the surface or through the solution. Cleanup technique include gel permeations, chromatography, acid-base Petri cleanup, solid phase extraction, and column chromatography. GPC used to remove high boiling point materials which condense in the injection pot of the GC or in front of the column. Acid-base patricians can be used to remove petrol water prior the analysis. Solid phase extraction can be used to various applications such as clean off the pesticide residues and chlorinated hydrocarbons. Chemical derivatization can increase the volatility and decrease the polarity of polar compounds. Stabilized compounds which are unstable at temperature required for GC improve the separations of groups of compounds on GC columns. The goal of sample treatment is the capability of using smaller amount of initial sample, especially for the trace analysis, achieving higher specificity and selectivity in analytical determinations to improve the potential of automations or online methods and minimize the manual operations. The usage of no or small volumes of organic solvents in order to approach the green chemistry techniques with less waste and more friendly environment. Data analysis can be qualitatively and quantitatively. We can use principle of the size, polarity, boiling point, and retention time to determine the components. We can use the area under the peaks to determine percentage of components in a mixture. The advantage of GC is it has high resolution power, high sensitivity, high accuracy and precision. Sample analysis very quickly. Small sample needed. And disadvantage is less application, lower column efficiency. Thank you for your listening.